Testing. Okay. Assalamualaikum and a very good afternoon. Yeah. So before we go for lunch, I try to speed it up. Okay. Overview of hormonal mechanisms. Yes. So you just had your lecture with Dr. Razik. So I'm just continuing for the function physiology kan. So part yang anatomy tu kita just breeze through je sebab we do the same. So you will have to refer details to Dr. Razik punya notes lah. So this is only overview, so kita tengok overview dulu because after this there will be repetition in other specific endocrine glands punya function lah in our subsequent lectures. So both lectures yang hari ini dah uploaded to Putra Plus ya. Okay, so okay. So this one is the overview, jadi general principles of endocrine physiology lah. So you also have reproductive from Dr. Hafiza, physiology. So that's why some of the endocrine hormones in here are not going to be discussed in detail. We just mention it in passing because you all dah belajar in reproductive module lah. Jadi mainly yang hari ni sampai pukul 1 ni kita nak tahu about the synthesis, regulation of hormone secretion, regulation of hormone receptors and mechanism of action. This is overall overview. So you will find some of these mechanisms and functional features that I've mentioned tu akan ada dekat all the other hormones that we're going to mention specifically gland by gland. I think endocrine ni dia tak susah sangat, cuma dia banyak sebab mechanism of action dia tu boleh more than one. So you must be familiar. Dia punya konsep tu taklah susah mana pun. Cuma dia banyak and dia pergi ke a lot of body parts, so that's why you akan tend to get confused. So biochemistry pun kita akan mention, but that is not going to be the main focus lah. But it is important to help you to understand. Jadinya this topic kita akan tengok hormone synthesis. Kita ada 3 jenis hormon saja. So peptide, steroid and amine. And then kita tengok regulation of the hormone secretion. So you know about positive and negative feedback, and I think this one pun it's not new for you kan. So you've had this in reproductive juga. And then the regulation of the hormone receptors. And then so you have down and up regulation. And then of course the mechanism of action. Okay, the mechanism of action in the notes tu adalah ada punya explanation, a bit detail, and you want a bit more detail lagi to help you understand. It's always in the textbook lah. So for this lecture, I will use one textbook which I find is the most macam quite helpful, straightforward and quite simple. Costanzo punya textbook. So as mentioned, kita punya endocrine kita punya hormones. Only 3 classes lah, peptides and proteins. We have steroid hormones and we have amine hormones. These 3 big groups. Okay, that's easy. So then hormones. So these are some of the intro. We have more than this lah, okay. So but kita akan tunjuk sikit-sikit je dulu, and as we go along kita akan top up lagi. So this is thyrotropin releasing hormones. So this one is based according to the type of hormones lah. So these are all peptide hormones. TSH and then GH and then PTH. And then under steroid hormones we have cortisol, aldosterone, testosterone, estradiol. So this kind of questions would be good for quiz or for you to like recall kan, sebab it's just very straightforward which group it belongs to. So dopamine, L-tyrosine, norepinephrine and epinephrine. So you can also see that like aldosterone pun dah belajar kan dekat urinary system. Jadinya ada a few yang repetitive, so it should also help you to understand it better lah. Macam dopamine tu kita tak akan sentuh banyak sangat in endocrine in this module because you akan learn a bit more of that dalam CNS lah. Okay, so hormones basically they can own substance. So peptide, steroid or amine, kita perlukan dia small amount sajalah dalam blood circulation. So these hormones will travel through the blood to go through the target organs. So target organs dia bergantung kepada what kind of hormones. Okay? So kalau you have sex steroid hormones, then it will go to the reproductive organs and also other sexual characteristic punya organs. So it is only only let into the blood circulation sikit saja. But even though sikit, kalau you are lacking, you are somehow genetically deficient, or there are some enzymes that are diperlukan untuk buat hormon ni, they are deficient, then susah lah, will be causing a lot of problem. So hormones, they are synthesized, secreted by endocrine cells. So usually in endocrine glands lah. You have a lot of endocrine glands, and these are some of it. Hypothalamus, pituitary. So for today, for petang nanti, 4 o'clock, this is challenging time. 4 o'clock is also a challenging time. So kita akan tengok hypothalamus and pituitary. So subsequent lectures in sampai January semua tu will cover the rest of those other organs. But like gonads, placenta tu, you already dah dapat lah during your reproductive punya module. Okay, I find this quite it's a good overview image to help you get the overall of mainly most of the main hormones, right from the hypothalamus, and then you have anterior pituitary, posterior pituitary. Tak semua hormones ada dalam ni, but a lot of it are in there lah. And of course kita ajar yang main saja. There are also other hormones yang kita tak ajar, but of course research and all that. But ini yang antara yang penting lah that you have to know. So ini pun macam you can see that like the hierarchy macam tu lah, sebab daripada hypothalamus, daripada atas tu you can see all the hormones from the hypothalamus. So these are the releasing hormones. Gonadotropin releasing hormone, growth hormone, releasing hormone, and then you have somatostatin, dopamine, and all this. This comes from the hypothalamus, and then dia akan ada connection, which is what we're going to discuss later, petang nanti. They go to pituitary, and then you have all sorts of other target glands, endocrine glands. So you have hormones that action on, will act on the thyroid gland, parathyroid, and so on. So like I mentioned, macam testis, ovaries, corpus luteum, placenta, this one you already covered in reproductive. So kita mention in passing saja. So peptide hormones, these are some of it lah tadi. Ini pun I just put it here to give you an intro saja, sebab nanti kita we will revisit. So this one is to show you some of the examples of the peptide hormones. So kalau hypothalamus, contoh hormon dia adalah somatostatin, and then the classification either one of the three lah. So for this one tadi it is peptide hormone. So dia punya action adalah inhibit secretion growth hormone. So for hormones, nanti after you have all had few lectures atau semua tu, you may want to do your own notes where you actually orientate yourself to hormone. For each hormone tu, you tahu dia datang daripada which gland, apa dia punya classification, what are the major actions, stimulating factor, inhibiting factor, and then dia punya actions tu macam ni is very general lah. So sebenarnya kita boleh further kita akan tengok in more detail lah. Walaupun the major actions dia ada can be subdivided lagi, because sometimes when you have blockage to the hormone receptor, walaupun your body produce a lot of that hormones, it will not have the physiological action, walaupun you ada hormone. Okay, so these are contoh of the steroid hormones. So again, this is just an introduction. You can glance through and see as a pengenalan lah, what are these hormones. But this one pun maybe you all dah tahu. And then also the amine hormones. Okay, so kita nak kena tahu sikit lah on how the peptide hormones are synthesized. So a lot of a bit more molecular, but it will help you to understand. Sebab at any point that there can be any disruption to the process, then you know that your hormone will not be produced, ataupun it will not be functioning normally. So kalau peptide hormones, sebab kita ada three groups of three classifications of the hormones tadi. So these are how the peptide hormones are synthesized. So you have the image, the figure, as well as a short description here. So kalau kat sini tengok, kalau peptide, dia dalam nukleus dia, gene for the hormone tu dia transcribe into mRNA, and then that mRNA is transferred to the cytoplasm, lepas tu on the ribosomes, and then you get pre-prohormone. And then that signal peptide tu, pre-prohormone tu, is removed in the endoplasmic reticulum. Then you get prohormone. Then prohormone transferred to Golgi apparatus, and then you packagekan dalam secretory vesicles. And then kalau ada simulation, baru those hormones are released from the secretory vesicles, wherever they are, whichever the endocrine gland is. So that is on peptide hormones. So kalau steroid hormones punya synthesis, I think this one you all had this during reproductive. So this is like revision lah for you kan. All steroid hormones are derived from cholesterol. So this one you boleh baca sendiri or just a revision. And then amine hormones pula, you have norepinephrine, epinephrine and dopamine. Contoh dia, so they all have the tyrosine lah as the common precursor. Then you will have these two enzymes, COMT and MAO, monoamine oxidase. So I think better pay attention to the monoamine oxidase, because in pharmaco nanti I think there's a inhibitor kan. You've also had this during your year 1 ke. So you just have to recall balik and revise balik lah how it works. So enzymes are also important. So enzymes are proteins, hormones are proteins. So not found in nerve terminals but in other tissues including the liver. But now is at presynaptic nerve terminals. Okay, so basically up to now it's all quite a lot of just revision from the previous modules that you have learned kan. How are hormone secretion being regulated? So hormone ni dia taklah sentiasa dikeluarkan ya. It can be turned on and off as needed. So bila ada stimulation or sometimes there's also inhibiting, so dia akan stop lah. Adjustments in secretory rates may be accomplished by neural mechanisms or by feedback mechanisms. Neural mechanisms ni, where you have for the secretion of catecholamines, you have preganglionic sympathetic, and then the synapse on adrenal medulla stimulated, and it will cause secretion of catecholamines. So neural mechanisms quite easy. Feedback is also you are not unfamiliar with feedback mechanisms lah. Okay, so feedback mechanism dia mostly dalam badan kita negative feedback, positive feedback ada juga but very rare. So it can be direct feedback or indirect feedback. Feedback can be negative or positive. Okay. So you have this also. I think it's very useful to have this kind of diagram, so for you to be able to understand. And for this negative feedback ni, belah kiri ni, the bagi contoh of the negative feedback. So you can have any anterior pituitary hormones that can direct feedback to the hypothalamus, and because dia sangat immediately after hypothalamus comes the pituitary, and the pituitary hormone yang keluarkan the hormone tu, that particular hormone sendiri will inhibit. Kat sini nampak negatif macam ni kan, that will inhibit the hypothalamus punya production of the hormones. So that is short loop, but it can also be feeding back quite long. So macam ni, hypothalamus pergi stimulate anterior pituitary to secrete the hormones. What are hormones? Sebab kita tengah cakap pasal overview. So and then the anterior pituitary katakanlah pergi ke testis gland. So it will stimulate hormones from the testes, and then testosterone will be secreted, and this testosterone will actually inhibit balik the hypothalamus, that is long loop, or it is also inhibiting the anterior pituitary. So that is negative feedback. So long loops, but short loops is like immediately after. Kalau long loops dia mungkin pergi ke beberapa organ dulu, and then finally feedback to the hypothalamus. So depending on the hormone lah, target tissue dia contohnya muscle for testosterone lah. So positive feedback ni ada tapi jarang. So this is an example of the positive feedback. So similarly, instead of inhibiting, dia akan stimulate lah. So estradiol, it's actually stimulating hormones from the anterior pituitary. Okay, that is right. means that some feature of hormone action directly or indirectly inhibits further secretion of the hormone. So hypothalamus basically hormon dia adalah hormone or inhibiting hormone. So it stimulates secretion of an anterior pituitary hormone. Anterior pituitary hormone ni dia akan act on the contohnya tadi testis lah. Okay, this one is as we discussed in the image tadi. Okay, right. So again, long loop feedback maknanya dia akan pergi ke bawah lagi sampai baru dia feedback balik to the hypothalamic pituitary axis. Short loop means that immediately the pituitary feedbacks on the hypothalamus. Negative feedback on the hypothalamus, so dia akan inhibit the hypothalamic releasing hormone. And then you also have ultra short loop. Ultra short loop means hypothalamus punya hormone ni dia keluarkan hormon kan hypothalamus. So the hormones itself is inhibiting the hypothalamus. So that is the ultra short loop. So contoh lagi negative feedback kalau insulin kan, you need insulin to regulate your blood glucose concentration. So like right now you are all hypo lah, blood glucose very low. But if nanti after your lunch nanti tu, so your blood glucose will become high, glucose high in the blood, so insulin akan dikeluarkan. So insulin ni can be turned on and off by changes in blood glucose concentration. So when you learn all these hormones semua tu kan, always go back and try to apply on yourself or among your friends, because this is all normal. What we are talking, what we are sharing today is what happens in you and me lah. Okay, semua sihat kan. So when blood glucose concentration is high, insulin secretion from the pancreas is turned on. So insulin ni, again, every hormone you need to know dia punya target organ or target tissues dia. So macam kalau insulin, a lot of target tissues. So that's why endocrine ni macam susah sikit sebab satu hormone tu dia punya function banyak and dia go to a lot of places in the body. So insulin, target tissues dia liver, muscle, adipose. So dia akan decrease blood glucose concentration back towards normal. So physiology is always about homeostasis kan, getting things back in balance. So kalau high, kita kena lowkan, kalau low, kita kena highkan, and that kind of thing. So when the glucose concentration is sensed as being low enough, insulin is no longer needed, its secretion is turned off. Kalau positive feedback ni, so uncommon, it causes more secretion of the hormone. Kalau negative feedback tadi, it inhibits the secretion of the hormone kan, but if positive, lagi dia menyebabkan more of that hormone is being secreted. So self-augmenting. Kalau negative feedback tadi, it's self-limiting. So example is the effect of estrogen on the secretion of FSH and LH by the anterior pituitary at the midpoint of the menstrual cycle. So recall your reproductive module. So during the follicular phase, the ovary secrete estrogen, acts on the anterior pituitary, produce rapid bursts FSH and LH. So these bursts dia punya effect ovulation and stimulation of estrogen secretion. Jadinya estrogen from the ovaries acts on the anterior pituitary, causing the secretion of FSH and LH. So there is positive feedback. So causing more estrogen secretion. So another example would be oxytocin. So again we have done this. So dilatation of the cervix causes posterior pituitary secrete oxytocin. Oxytocin stimulates uterine contraction, causes further dilatation of the cervix. So the explosive event is parturition or delivery of the fetus. So dia secretes more of it, of the oxytocin. Okay, now we move on to feedback mechanism habis. Next we move on to regulation of hormone receptors. After hormone receptors, then mechanism of action. Okay, regulation of hormone receptors. Responsiveness of a target tissue to a hormone expressed in the dose-response relationship. Maknanya magnitude of response is correlated with hormone concentration. Tadi kita cakap hormone is released in a very small amount in the blood circulation. So sensitivity is when the hormone concentration that produces 50% of the maximal response. Maknanya katakanlah we need 10 units of that hormone to actually get the maximum response is 100, but with that 10 unit of hormone we get 50% of the maximum response of that 100. So that is the sensitivity lah. Tapi kalau we need like 20 units, tadi kita cakap 10 units of that hormone, we get 50% of the maximum response. But now if we actually need 20, more than 10 units tadi, we need 20 units of hormone to actually get the same amount of that maximum response tadi, 50% of the maximum response. Then maknanya that hormone has already got decreased sensitivity of the target tissue. But instead, if it only requires 5 units of that hormone, then maknanya there is an increase in sensitivity of the target tissue. Regulation of hormone receptors. How we can actually modify or regulate these hormone receptors is either by changing the number of hormone receptors. The hormone receptors, you imagine hormone, the hormone and the receptors. Hormone is being released by all the endocrine glands, and then they travel to the target glands kan. So the target glands ni dekat dia punya membrane surface dia akan ada receptors which are made of protein juga. So they only act when the right hormone comes to attach to the receptor. If dia tak akan bind with other hormones yang tak berkaitan. So only when that happens, baru the next physiological event will happen. So the number of receptors tu can be modified, can be regulated, as well as the receptors for the hormone tu, the affinity for that hormone can also be modified, can be regulated. So the greater the number of receptors for a hormone, the greater the maximum response. Makes sense kan? So dekat glands tu, dekat the muscles, they have receptors for testosterone. So dekat muscles tu, if there are more receptors for that testosterone hormone, then you get maximum response. The higher the affinity of the receptor for the hormone, the greater the likelihood of response. So kalau it's not about the quantity, but the affinity of the receptor too can also be regulated. Maknanya you can still have the same number of receptors, but the affinity of that receptor to that hormone is increased. So the down regulation, of course, is easy. Is the opposite of that up regulation. Okay, when a hormone decreases the number or affinity of its receptors in a target tissue. So the purpose is to reduce the sensitivity of the target tissue when hormone levels are high for a long time. So there are times when the hormones can be chronically high. So the regulation is, one of the mechanism is to actually down-regulate the hormone receptors. So to down-regulate that, either kita kurangkan the number of the hormone, that particular hormone receptor, or kita reduce the sensitivity. So decrease the synthesis of new receptors, or increase degradation of the existing receptors, or inactivate the receptors. So receptors are at the surface of the membrane semua tu, so it's also by proteins, so that's why you can see the word synthesis, degradation, and all that. So that is how we regulate. So you have the feedback mechanism. So ada beberapa mechanism lah, to control, to always control kita, macam ada beberapa strategi kan, to always try to maintain things in balance. So this one we are talking about the hormone receptors itself. With downregulation, the response to hormone declines even when hormone levels remain high. So katakanlah effect of progesterone at its own receptor in the uterus. So the progesterone can be very high in amount, but when the hormone receptors is being downregulated, so then the response to hormone to progesterone can be reduced. So it is also referring to hormones effect on receptors for other related hormones. So maknanya progesterone pun boleh downregulate receptors for estrogen. It does not just regulate progesterone receptor. Progesterone downregulate progesterone receptor, betul. Progesterone downregulate the receptors for estrogen pun boleh. So lagi example, triiodothyronine in the thyroid system decreases the sensitivity of TRH receptors in the anterior pituitary. So because sometimes when there are high levels of T3, they can reduce the overall responsiveness of the hypothalamic pituitary thyroid axis. Hypopituitary thyroid axis, which will to cover nanti petang. So upregulation of hormone receptors, tadi tu down regulation kan, so it's the opposite of that down. So instead of reducing, kita increase the number of affinity. So how do we upregulate? Is via increasing synthesis of new receptors, decreasing degradation, or activating receptors. So you can always do this kind of things in a table to compare side by side kan. So it's quite easy kan, it's quite straightforward. So downregulation, upregulation of hormone receptors, you compare, it's the same thing, keyword, satu increase, satu decrease, janji tak terbalik kan lah. So prolactin increase the number of its receptors in the breast, growth hormone increase the number of receptors in skeletal muscle and liver, and then estrogen increase the number of its receptors in the uterus. So the hormone as well as the target organ. Upregulation, mechanism of action. Tinggal lagi 3, lepas tu boleh habis. What are the mechanism of action for the hormones? Hormone actions on target cells. So hormone ni tadi kita cakap it's being released in small amounts in the blood circulation, so it should go to where its own target cells. So bergantung kepada hormon tu hormon apalah. So hormone in general dia akan bind to a membrane receptor of the target organ. So dia akan form hormone receptor complex. And then this hormone receptor complex ini dia akan couple to effector proteins by G proteins. So after that, the effector proteins ni, it can be enzyme, can be adenylyl cyclase or phospholipase C. So enzymes play an important role juga in our normal physiology. So that's why kadang-kadang there are genetic link diseases which cannot actually translate into enzymes, so dia akan jadi problem if some individuals who do not have certain enzymes in the body lah. Okay, so because all the time kita need the enzymes lah for physiological punya mechanism. So when effector proteins are activated, you can have a second messenger, so either CAMP or IP3 being produced and amplify the hormonal signal. I think you've had this before lah kan, you pernah belajar kot masa year 1. So some of the major mechanisms kita akan focus mainly on the 3 sajalah. The 3 is what is being focused from Costanzo punya buku ni. And when we go to the particular target organ tu, endocrine gland, kita akan mention jugalah what kind of mechanisms that the hormones are involved in. So kalau adenylyl cyclase ni, a lot of hormones use this mechanism. So what it involves is the binding a hormone receptor that is common to all, and then dia akan couple to a GS or GI protein, and then dia akan either activate or inhibit the adenylyl cyclase lah, increase or decrease sebab depending on which dia akan couple dengan which protein, amplify hormonal signal, and then you get physiologic action. That is as an overall. So specifically for adenylyl cyclase mechanism, you have the figure and you have the very brief description. Okay, you might have in other books juga lah, Guyton and Gagnon, tapi you can use this note as a guide because I do not expect you to be too detailed in terms of the molecular punya pathways ni semua lah. Okay, it's good to know, it's nice to know, but the more important thing is when you can actually interpret the processes and the mechanisms too into other physiological effects. Sebab ini a bit molecular, but it actually also forms a basis for you to understand nanti pharmaco and then in the future pathology juga lah. So that's why it is still included in the notes. So taklah nak suruh hafal, but it really helps you. So you still kena baca juga lah. So like steps are, you can see atas ni inactive and bawah is active. So we talk about the active one lah. So active one is when the hormone binds to the receptor and they produce conformational change in the alpha S subunit. So hormonnya kalau dia match, dia akan bind betul-betul lah. Kalau tidak, maknanya yang tak berkaitan apa-apa ataupun somehow either the receptor tu tak betul-betul shape that it cannot match the hormone, then this binding will not happen juga. So once it binds juga, dia akan produce conformational change, and then produce two changes lah actually. So one is you have a GDP being released, and then second one is you have it replaced by GTP. So replaced by GTP, and the alpha S subunit will detach from the GS protein. So as the alpha S GTP complex migrates, dia within the cell lah, dalam sel tu, dia akan bind to and activate the adenyl cyclase ni. So this one, once it is activated, dia akan convert ATP kepada CNP. CNP ni is the second messenger lah, and CNP ni via a series. So ini pun dia dah ringkaskan sebab via a series ada banyak lagi step, tapi dia dah ringkaskan. Will involve the activation of protein kinase A. So then dia akan phosphorylate the intracellular protein, and then you akan get the physiologic actions lah, depending on what kind of hormone. So ini dia terangkan as general hormone. So whatever hormones yang menggunakan adenyl cyclase mechanism will use this. Then we go to phospholipase C. Tadi CMP kan as the second messenger, but as for phospholipase C, kita guna IP3 calcium as the second messenger. So it involves binding to receptor sama macam tadi, but now dia punya protein yang dia couple lain. This is GQ protein, and then contoh-contoh hormone with this mechanism, inilah gonadotropin releasing hormone, teratropin releasing hormone, growth hormone releasing hormone, angiotensin 2 typos, ADH and oxytocin. So again kita bagi figure, Costanzo punya figure ni, and then the very brief steps. So you can see the active one. Again, you can get the hormone receptor complex ni, dia akan bind, and then dia akan cause some changes, and you will get the GDP is being released from the alpha subunit, and then you get GTP replacing it, and then the alpha subunit detaches from the G protein, and then the complex ni akan bind to and activate the phospholipase C. So once it is activated, dia akan cause the liberation of the diacylglycerol and IP3 from the membrane phospholipid. Kita tengah cakap dekat membrane of the target cells ni, and then IP3 generated ni akan cause the release of calcium from the intracellular store. So you akan dapat increase intracellular calcium concentration dalam cell itself, not outside. We're not talking about outside, it's still inside the cell. So this calcium and diacylglycerol activate protein kinase C. So macam yang previously tadi pun, dia akan activate protein kinase C. So once that is done, phosphorylate protein, and then you get the physiologic action. So another mechanism, steroid hormone, I think that you may have covered in repro. So steroid hormones and thyroid hormones have the same mechanism of action, and they both guna IP3 calcium as the second messenger. Okay. So steroid hormones, ini briefly lah, so, just briefly, just about, I think you have this already. So steroid hormones will act slowly, and then unlike peptide hormones, they act within minutes. When compared to peptide lagi cepat lah dia punya action. Again, we have this, you can see at the image and the description here. Dia kurang sama je, but you of course you have steroid and then receptor, conformational change. This transcription is slightly different daripada yang tadi lah. Okay. There are other mechanisms of course, but kita tak perlu tahu in detail lah, sebab the main mechanism of hormone of action for our interest, yang main hormone ni all covered by this, adenyl cyclase, phospholipase C, and steroid hormone mechanism. Yang ini nice to know. So insulin maknanya guna tyrosine kinase, not adenyl cyclase. And all the others tidak menggunakan adenyl cyclase, but majority memang adenyl cyclase lah. So mechanism of action for G proteins, this one is not mechanism of action, but more of description of the G proteins lah. So G proteins is actually the family of the membrane. So it serves as molecular switches, and there are 3 subunits. You have alpha, beta, and gamma subunit. So it can bind either GDP or GTP. So kan kita ada the image tadi tu ada part when it is inactive and when it is active. So bila GDP yang bound, then it is inactive. Kalau dia active tu maknanya GTP, GTP is bound. So you have GS or GI, meaning that GSS is for stimulatory and I inhibitory. Habis, right? That is the overview. Dari petang kita learn a bit more on the hypothalamus pituitary itulah. Okay. Okay, and then esok